And we are, I guess, going live. Let me just check my control panel. It is here. What's going on? Mouse Phantom is here. Okay, yeah, we are live. Good. All right. So today, it's the last stream before paper one this Wednesday. And let's see. I've got some. So I have this, but it's kind of this is a trace, but it's an assembly trace. So that's kind of paper two. I thought we could maybe have a look at the theory questions of. Now those are zigzags, and I don't. I mean that's right. Let's not get it. Let's not be unfair. Particularly against the mark schemes. I reckon I'm also going to pull up the old physics and math tutor, not revision. I want past papers. Yeah, best paper, AQA paper. Let's go here. A level, A paper one. I mean, there's some AS paper one that might be interesting to do as well, but let's see what we've got if we can do paper one. Because there's some section A, I mean, so it's all the first part of the spec paper one, right? So it's kind of like you get your data structure, I think, in there. But like, if you have a trace in paper one, so if there's a table on the electronic answer document, it might be a Dijkstra trace. 21, 2020, the one that never happened. All right, 2018, why not? I think I've looked, oh, this is the instructors remark. Made a separate document for the. Up. The other day, I was on this, and so sometimes they show you some PMT. What's this? This physics? Now that's a little operational amplifier. Oh my god, this was my nightmare when I was in anyway. Oh, hello. Oh, I love those. So paper one, section A will often start with literally basically a riddle. So 2023 was like the one with the piece of paper. 2021 there was one about like kind of a who done it, who's done the crime type thing. There was another one about like kind of which of the statement is true, and there's a whole bunch of them say that all refer to each other being true or false. I said that one to my year 7, so it's quite a fun one. Okay, so that's not the riddle thing. Oh, bubble salts, yeah. Well, all right, let's pick 2018. I'ma open a okay. So you advise to spend longer than 45 minutes on this section. I'm gonna set a timer for it. I'm gonna right, P1 28. Can I edit like 2018? And can I hopefully edit markdown straight in there? Section A. How about I'm gonna download this and use the aptly named finder to find it, and then chuck it right in here. I already have I already have this one. Yeah, okay. That's the one. Yeah, this is what I'm looking at. No, it's not. This is section B. The whole thing problem, god damn it. Oh yeah, hello. Oh, I love this stuff. Is that the same one? Yeah, 3 boxes, yada yada. Okay, cool. Hide this. I might like put this over here and hide my bottom. Not this one, it's J, the bottom bar. And well, yeah, the trick for the trace table question is to just trace it. Oh no, sorry, the trace table question the program does, then once you figure it out, like that should become apparent when you look at what you came in with and what you come out of. The one you might be thinking about, I mean, I don't know if you're referring to that one. Spoiler alert, this assembly program, that's a paper 2 question. Zoomy, Yeah, I need to zoom you over there as well. So this will actually, it's blatantly obvious, right? Like when you look at this, you don't know what it does, but once you look at the final trace table, we're starting 34 and 6, and we're gonna end up with like 5 and 4, and basically those are like the divider, you know, it's like 34 divided by 6, it goes in 5 times with a remainder of 4. So this is arithmetic, I can't remember what it's called, just kind of like old school division, kind of, you know, with reminders, right? The kind of integer division, I guess. Yeah, if you stay in the integer domains set, you're good. Okay, I'm just gonna put this away in the back. All right, and zoomy. Yeah, invest to spend no more than 45 minutes. Well, we'll find out. Booyah. Well, now this is... Actually, I probably can do it like... Let's do it like this. Question 1.1. Yes, I tried many times. I made many videos about it. I've posted none, and then on the last live stream last Sunday, you know, I kind of got it where ZigZag wanted it with their test case. But there's the problem with the brackets is, like, you know, if you get a starting bracket, you need to make sure you handle that correctly, and I couldn't handle the end, having a bracket at the very end. So I basically spent another hour on this and got super frustrated. It's not going to be the brackets. Like, it's far too complex to be the brackets. What it so I reckon, okay, you get two small ones, two big ones. Something like a basic thing to change the flow of the game, like quit. That's the first ZigZag one. Something like accepting spaces. That's also a good one, because there's the question of, do you use the regular expression? It touches the regular expression, but there's a way of bypassing this completely. Definitely exponentiation, your caret and your powers, because you need to know the precedence and stuff, and that would also probably be an 8 marker, I don't know, like something like that. The big ones, like this is where I'm at a loss. Brackets are too complicated. Something like accepting postfix expressions directly, and then being able to detect and put them like in the right place. I don't think an auto-solver is on the... I don't know, maybe an auto-solver, I don't know. Like the, you know, ultimately you need to prepare, it's the code you prepare for, not the questions, right? That's the philosophy of the skeleton code. But section A. Yeah, I did spend 2 hours on it, Valsmatter, thank you. I didn't want to, it's just like I get a bit stuck in. There's a sort of pride of like, I need to solve the programming question. There's children watching, I set an example. All right, so... describe how you can work out what each section you can do by sticking just one vegetable out of one box without looking inside any of the boxes. Well, so it's like, we've got like O, carrots, O-N-C, O-C. We don't know what they are in, but they know that all 3 have been labeled incorrectly. That's the key part, right? So like this cannot be O's. So if I find O, so if I were to pick this one, if I find an O, it's O-N-C. L-F, if you will, like, and if I find a B, this is going to be, sorry, carrots, C. If I find a C, it's going to be a C. This is the reverse. Onions and carrots tells me nothing, because it can basically be onions or carrots, so I'm like liable to find any of those. So and that's enough to find, because once we've locked it in, this is something, there's only 1 degree of freedom in the table. Let me show what I think. So, pick one from the onion, the box marked onions. If it's a carrot, this is the carrot box, which means the onion and carrots, therefore the OC box, incorrectly labeled. could only be O or C, has to be the O box and the box marked carrots. So, okay. Right, the box marked carrots and onion has to be the onion box, and the box marked carrots has to be the carrots and onion one. If it's an onion, the box marked O has O and C, so the box marked C has O, and god damn it, no, that's good, and the box marked O and C, this is like 5 minutes, this is a nightmare, has C. No. Yeah, that's fine. Okay, yeah, cool. That's 2. All right. Fine. Yeah, I need to move a bit faster on those. 1.2. It's 5, 3 minus. Hash. They will throw you like a sort of tricky Ridley question. Don't get stuck on the third one, because you can end up like me and spending, like, learn from my mistake of spending 2 hours on the effing brackets. And like, don't get stuck, like, move on, you can come back and so on. Like, it's better to have a good scan and do it breadth first before you get stuck in the depths. This is, so what we have here is kind of this brackets here, right? So this will be 3, 4, 2 star plus 1 minus. Question, why are we at 2.3? What's going on? Oh, we're at 2, sorry, this is like 2. I mean, I would have an electronic answer document, so I'm not counting this time here. I just need to pay attention. So we're at 2.3 on the level 3. Questions on the next page. Why is it so? There's 2 marks here, right? You see, read the question well, read the full question. Reading the question is half the answer, and like, read the number of marks, because you don't answer a 4 mark like you would a 2 mark. No needs for brackets. Evaluates with a stack. Which is convenient. I think those are probably kind of 2 enough. Yes. Yeah. Okay, so explain. This is an explain, right? Remember the action word as well. This is 2, 4. So this is an explain of how we would evaluate. Is it this expression? Evaluating an expression. Even if you kind of end up writing full sentences, but you don't have to, like, think bullet points to see like whether you get the mark. So first we read the expression. Also, it's an algorithm. Like, surely you kind of, you read the expression left to right. Numbers, operands. Numbers operands gets put through the stack if reading and countering, reading an operator, pop, operate, push, right? You kind of push back onto the stack. Yeah, and once the expression is finished, so this obviously won't be, there won't be, I don't know, I doubt there will be something like this on section A, because you've got this all the way in section C's and D's. But like, you could have something like this. You definitely would have something on section C, because this is the theory question is like, let's use the code to ask some theory questions, and the code in that instance has regular expressions. I don't know how much there would be here, but like definitely, you know, kind of mathematical expression notation and conversion and evaluation. When the expression, the like input, the result. Boom. Stack sum was stack frame, two components of a stack frame. So this is like book learning, but your stack frame has the state, so that like variables and then a pointer to where to resume execution. But that's not always the case. So Python, being a high-level language, will not really have this in an explicit form. Like assembly will need to know where to return, but we're not, you know, this is exam, not knowing. Okay, okay, helpful. And now question 3. Hello. It's a graph determines the location. Oh yes, I remember this vividly. Okay. Fine. All right. So tables in Markdown is like pipe 1, pipe 2, pipe 3, pipe 4, pipe 5, pipe. Pipe 6. I get 6 of them here, and we need another. We need like a blank one here. Probably get a space. 1. So 1 to 1, all of them are, you know, x'd. 1 to 2, all the diagonal, I mean, right? 1 to 2 is 2. 1 to 2 is 2. 1 to 3 is 5. Yeah, this is where I did the Dijkstra actually. I'm not gonna. I was gonna skip the Dijkstra twice because it's in this one. That's what was at 2018 on the thing. In my Visual Studio folder. So that's good, because like there's probably like 20 minutes of the 45 minutes of the Dijkstra tries. So I don't have to worry about this. 1 to 4 as a distance. Time saved to travel, so a duration of travel. 3, 1 to 5 does not connect. I'm gonna note those as what's happened here. There's a mistake here. Yeah, 1 is going to 1, 1 to 2 is 2, 1 to 3 is 5. Why? I'm speaking when I'm typing, that's probably the problem. 1 to 4 is 3, 1 to 5 is x. 1 to 5 is... that's because shift is right next to my up arrow. Oh my god. 1 to 4 is 3, and 1 to 5 is... 5 is not connecting, not x, but blank, and 6 is 8. And that's your 1. Then you get your 2. Now your 2 to 1, we've already done it. It's 2, but like I'll fill it in fully. X. Can I just annotate the thing? That wouldn't be, that'd be nice. 2 to 3 is 1. You just keep doing this. It's an adjacency table. And so because your graph is not directed, it will be symmetrical along along your kind of like identity diagonal, as we call it. Whereas I'll have a look if it's at the bottom of the trace. Is there a trace? Oh yeah, so that like this is, it doesn't tell you exactly, well, it does tell you it's Dijkstra, right? But like P is, I mean, I pull up the stream, but like I think I answered that question in the stream. This idea of like, you know what you end up with P, and P is like, which is the previous node we came from to get that shortest path that will be in D. All right, back to this guy. Okay, I'm looking at 2 and 4. 2 and 4 are connected, they're not connected. Underscore 2 and 5 not connected. 2 and 6 not connected. So 2 is only connected to 1 and 3. And that's right, yeah, all right. 3. 3 is connected to 1 to the tune of 5. 3 is connected to 2 to the tune of 1. I'm just mirroring what's going on there. X. Then the 3 is then not connected to 4. It's not connected to 5. And it's connected to 6 with a 4. 4. So again, mirror, mirror on the wall. 4 is connected to 1 with 3. 4 is connected to 2 is not connected to 2, not connected to 3. It's connected to 5 with a 1. And to... you'll be fine, don't worry about it. Like in 10 years, you won't care. Or even in 10 months, in 10 days after the results. And then to 4 to 5, no, 4 to 4 is an X, sorry, 4 to 4 is to itself, 1, a 4, and 4 is not connected to 6, right? 5, so it gets easier as I'm just kind of like mirroring what's going on. It's really about like typing and keeping the thing straight. It's 5 to 1, no, 5 to 2, no, 5 to 3, no, 5 to 4, 1, 5 to 5, X, 5 to 6, 5. And 6, now I've got the whole column here, so I'm just kind of copying this column that's going on there, right? 6 is 8 underscore 4 underscore 5 underscore X. Boom. That's your adjacency table. So that's 3, 1. Okay, I got 30 minutes left. Most of the table. Just store neighbors, not weights. It's simpler. Like, whereas if you want something complex like this, it's better open to a table. Arguably, if your graph is not directed, you kind of, you know, an adjacency table will, because here we're duplicating the data, right? But I'm not going to list it because weighted graph ultimately are best represented like this. I don't know. Best displayed like this, whether represented in memory. Yeah. One reason, plenty, but 3. It has a cycle. I think you can do like, you know, kind of like 1 from, you know, 1, 2, yeah, 1, 2, 3, just like, it has cycles, plural, e.g. 1, 2, 3. A weighted graph, the edges slash arcs connecting the nodes slash vertices have numerical values attached to them. Can be used to represent distance, time, cost of a move. Still very fun stuff. I love graphs, and I mean, I've got some really cool programming stuff, but it's really at the far edge of kind of A-level material. So I think like at this stage of the game, no one's really interested in watching that. You want something immediately useful for the papers. I'm not doing this because we did it 2 weeks ago, but you know, 7 marks. Remember, right, this is 2 hours 30 minutes, which is 150 minutes, and there's how many marks? 100. So it's like 1.1 minute and a half per mark. So 7 is kind of like 15 minutes and 1 hour. No, that's like 10 minutes. Wow, okay. We've done this in the previous stream. Describe the halting problem. Fear of computation is super interesting, slightly sadly not my forte because it was taught by the other teacher when I taught A level. The halting problem is that it is impossible to write a program that will read and establish whether the program being read, not the program that was the program, will halt. Yeah, for all programs. Obviously, some trivial programs you'll be able to do it from read. The limit of computation, the Turing machine. All programming languages. Ergo, you can't. Because you can't solve it with any computer. That was like far too long to have this answer, but I'm just kind of ensuring I'm getting the marks. It's like okay. It will have a that was like 4-2. Reading head, and then, you know, kind of reels motors to move the tape related, or move the head there. I mean, universal Turing machine is like a sort of ideal, a notional, kind of like now it's just like a GM with infinite tape and the ability to. Does it have an infinite alphabet? I don't know if it has an infinite and the ability to work with any alphabet of symbols. I'll just word it like this. Okay, yeah, I see what they've done here. Well, in practice, I'd much rather write code for an actual computer. You can, so because all Turing complete languages are equivalent to a Turing machine, you can basically rewrite everything in thing. They are like arcane, deliberately obtuse kind of comedy novelty languages. I can do a stream about this. One is called mindfuck. It's just like 4 characters. Literally, it's like move forward, move backwards, read, write, or something like this, and you can do all computation in this for an actual computer / language. Right, question 5. Section B. All right, okay, that was it. That was 45 minutes. All right, right. Well, I've probably got time to mark it. Whew, I was worried. I was like, oh my god, it's exam time. Okay, cool. No, we're fine. We did the extra trace the other day. All right, let's just have a look at the Maze. El Schéma de marque. 2018 Maze. Boom. All right. Yeah, boom, boom. Yeah, okay, so that's 2 marks. I got this, I got this, I got this. Simpler to evaluate, simpler to code algorithm, do not need brackets, no need to precedence. No need to backtrack when evaluating. Yeah, but I've, I guess the stack evaluation, I mean, you know, that's 1 out of 2. Benefit of doubt, that means BOD, right? So like you would accept this. Cannot be ambiguous, that is true. Evaluates with a stack, I think I would accept kind of, well, it's simpler to code the algorithm. It's kind of what I mean by this. That is true as well, so nothing to say. Starting relation, you push this to the stack, two values, apply, add the results, it's your evaluation. Local variables return address parameters, register values, accept examples. That is, yeah, 0. I don't know about 0, because like that means that literally would be red. I mean, you'd make a, I don't know, because you could have a weighted graph where things are connected, but there's a weight of 0. So like I would put like an NA or, yeah, alternative answer only half of those. Yeah, thank you, just in case. Zeros in correct places, all of those correct. Ignore non-zero symbol used to denote no edge, but only for showing no edge going from a node to itself. Right, so I wouldn't get that mark because I'm sorry, I disagree here. Like this is very, I mean, you know. I don't know that it's, because this is correct if you assume all weighted graph to have a non-zero weight, which, you know, for the kind of practical problems you solve with weighted graph is true. But yeah, I guess it might be right. Fair enough. Fair enough. Okay, so I don't get that one. Sparse, graph matrix is sparse, so the is connected. Not enough few edges. Well, okay. Few edges between vertices, yes. Edges really changed. Oh yes, it is if your graph are mutable something. Presence absence of does not need to be tested frequently. Okay, I wouldn't have yeah, because it's simpler to test when you kind of look it up in a matrix. I think I got one of this as well. Contains the cycles. Yes. Yeah. Okay, the Turing machine ones are not going to be so hot. We've done this. To store the previous node location to the path. Yes. To be recreated. To store the path. The program will halt without running the program for a particular input. For any particular input. Non-computable and decidable. Inspection no one can determine. Yeah. The Turing machine is. I mean, this is the one about the Turing machine. So. Yeah. No algorithm solves the halting problem. Yeah. Finite set of states. Set of transition rules. Sensing right head. Okay. Any other. Faithfully executes as specifically similar description and determines the interpreter. Yeah. Okay, I would have started with the infinity tape. I don't know if I've got the marks on this one. Hi Nepali man. Right, so that was like section A. Section B, that's the prime one, we've done this. Section C, well this is we can have out of the thing. Right. Well, that was just kind of A, essentially. Let me just save it. Maybe like rename it as... The underscores are a bit like old-fashioned, but this is how AQA publishes it. So how about not the coding task? Did I not have the? How about the theory questions? No right on, non-right on. Okay, and then yes, another one like, so this is the ZigZag sec C dot markdown. Do they put a time on them? 57. I mean, you did that. Oh my god, are you joking? Fine, all right. Yeah, no, actually, this is probably a good one to do, but I'm glad we did it at the end because I think like you'll find those much. Well, they appear before in the exam, obviously, but you'll find those much easier to do once you're familiar with the code. Okay, Napoleon is asking for the skeleton code coding in the exam. The questions guide you to answer the question. Yeah, I mean, like, again, have a look at past papers. They will break down what they call tasks, and in fact, a question may have more than one task. They'll be like, kind of, create this method and add this, and they're really, and so in a way, they will also verify that you have done this, and they would specify it much better and much. Yeah, recursive method on the. I'll put it on the list. I might do it after that, unless there's something better that comes up, because that's kind of an exciting one. But again, I feel like this is kind of less practically useful, a week or 10 days before the paper, because I just do it. I mean, it's at least, yeah, simpler to understand if you do it. Even the brackets, probably the bracket conversion could be quite elegant to do recursively, but what can you do? Okay, so we'll get this here and the PDF there. Right, 1A. The choice variable in the main subroutine so that either y or y will result in the training game. And always, or don't, yeah, always like adds 119 at the end or something. Question mark? I think the 119, the fact that training, I'm not gonna. Well, actually, to be honest, I'm doing this. I should have the code open. That would be kind of helpful. But this, right? So every time you refill the numbers, which was add operators, like refill operators. In play game, we do fill numbers. Yeah, fill numbers. You just return it. No, sorry, it's not fill numbers. It's like update targets. Oh, you just plumbed like whatever was the last one. So it's not one. It will end up being 119, but then yeah. Oh, yeah. You have Connor Carton is saying, okay, we get some Turing machines last year. I mean, Connor, I haven't seen the 2024 question paper. I'm a bit gutted about this because I made some kind of, I was working with symbol puzzle and stuff. And also I get like some, students that graduated and stuff. But if you, yeah, I wish I could have seen that. I think Connor is saying there was Turing machine last year. So hopefully, it's not going to be that this year. And yes, if in your electronic answer document, you have two tables, that it's definitely a graph, and it could definitely be a graph like the 2018 one, right? So like first do the adjacency thing and then the trace. Hamza, remember your training and just kind of like trust yourself and proceed methodically, right? You've seen that on the adjacency table. You just kind of look at the numbers and put them down, the trace, and we can do it again. But all right, so training game, play game subroutine, let's display state. Play game subroutine will display state before the input and repeatedly as in the loop. Yes, of course. Well, we obviously kind of such a dumb question. I'm sorry. Unless. And then once that's the second mark, right? So repeatedly it calls them once. That's because it appears twice in the function. It calls it repeatedly in the loop. Final score. Boom, boom. Free a user input. Just like it, users, I mean, like it's literally the name of the variable in RPN, used to find operators. the available numbers from the available numbers, yeah, whatever. Explain the logic. It's an explain. There's 2 marks. Explain. This is in remove number used. We go over each of the number, and if it's a valid one, we oh yeah, we found there was a bug. They might ask you to fix a bug. There's a bug that you can use numbers that are not in the allowed numbers list because it doesn't check it's a valid number. There's something there that they don't get removed. So you can just kind of like take a massive number and divide it by whatever the others to get to the thing. But like, so it checks if it's valid because why not? Oh yeah, so that checks that this is basically only the operators, and then it will use removes. Int item in numbers allowed. So this, yeah, that's fair enough. Item here is a string. That's the important thing. So we use everything in user input and RPN are strings. So check valid number, we use check valid number because it checks on strings. And then we do another check to check, yeah, that it's a number, and then it is in the numbers allowed and gets moved from it. So 2 iterates. Is valid number, what's it called? Check valid number. I mean, like, this is Jai is asking, do we have to print the paper in the time? And they I think they will give you some flex, right? Like usually it's like it depends on the examination center. The board might kind of like ask for like it to be done within the time, but it's a whole nightmare because it depends on how many kind of students you have and so on. So I don't think that should be the case. You kind of like just say I'm done, and then they would take the file and print it out. I was invigilating the on computer GCSE at Excel's got a paper too that's like on comp, and then when they finish, and even, you know, I was invigilating some regular exams where like students have got laptops, and when you finish, and they kind of go and take you with you and print it out, and yeah, that's not taking from the exam time. Your school might say that because it's possible that that might be the school's policy. I think my mic is not as hot as I. But no, I'm good. -10. My eyes, yeah, disappointed, but. You can, you know, if it comes to that, you can argue over it. I think they say that if they've got, you know, few students and the time to print it, then cast to an int, and if the number is in numbers allowed, it gets removed from it. Boom, boom. 4a. Check if user input evaluation and target how it works. What condition needs to be met to increase the player's score? Check user. Yeah, but no, it's user input evaluation is a target. Check user input, that's the one, right? That the evaluation, the user, well, I don't know. The result of the expressions evaluation should be in target. That's the point. No, that's B, right? It's and B, sorry. Because to blank to remove. Blank spaces are noted -1. You notice I'm kind of, I don't even need to go to the code for most of this because you've worked on it so much. Well, yeah, 2023 was like all input validation. That was kind of, that was an interesting one. 5. Check valid number. It is a regular expression. Right. Explain. Right. 2 marks. So A. So that regular expression in check valid number. So Godwin, Dominic, you know, the NEA is 20% of the mark, right? Which means that the NEA is worth as much as section C and D. Have a think about the amount of time you've put in the NEA. Really, you should put as much time in the section C and D. And I feel like time pays better in section C's and D's, but it depends how much you like programming, I guess. All right, so explain the purpose of this regular expression in the function and how this regular expression works to validate other input. This expression in the function will check that the purpose, the string in item is an integer. It does so by checking that okay, it does so by looking for the start of the string. You can mention, it's like caret, start of the string is caret. 1 or more digits, meaning, so digits is 0, 9, like this, with a hyphen. 0, 9 for digits. Then the end of the string, and that's dollar bill, meaning the whole thing is an integer. No, I don't think they should always be the same distribution, right? It's about half and half. A and B is one half, C and D is another, and yeah, this kind of like, and within that A is like 75% of the, yeah, but the timings may not be the same. This is what's interesting. B, the expression integers smaller or equal to 10, right? Because if you change it by removing the plus character, it means it's like just a digit as opposed to 1 or more digits. So it will kind of accept numbers from 0 to 9, but rejects the other. 6, evaluate RPN function, RPN. Notes. Well, you can define it with like a BNF, right? Because it's like is operand So this is a recursive definition of things. So the operators, the operator is after on the operand. To evaluate it with the stack. So this is helpful, right? Because they might ask you this, which is the same question we've had in 2018 section A, but this time you have this. So, I mean, it might help you. It might make you waste time of trying to like figure out how you evaluate based on this. It's before the displays for some reason, right? But like you look at what's going on. If it's not an operator, you append it and you pop this, you remove it from it. And then when you're here, it means you've encountered an operator, you pop them, you work them out together, you push them back on, and then you repeat until you're at the end. And at the end, what you have, like, it's S0, it's kind of like the one thing you get left on the stack is the result. So I've explained this in the, you know what, I'm just gonna, you know, I'm like, I've got limited patience with this. You can rewind the stream. It was like here, right? And card box, yeah, boom. Hello. We're open if I'm saying this function. So in this function, a divide by 0 would be here. We would have an exception would be thrown, and because it's not caught in evaluate RPN or any of the, yeah, okay, so I might need to write it. 6, no, it's when B. An exception will be raised, and as it is not caught in evaluate RPN, is what it's called, evaluate RPN. Yeah, I think you're right about the breakdown of the oh my god, there's some tea in the chat. So hey, chat, like as a collective noun, am I doing this right? No cap. Ohio Skibidi. No, this is probably for people a bit younger than you, seniors. Yeah, Hamza, you're not wrong. The examiners really even check the NES where they just thought this most of the time. This is done. I was looking at this, right? Because like you're a teacher. Right? Imagine you're a teacher of computer science and you're looking for like make a bit of money in the summer. If I just show you like my browser history, I was on AQA's work with us. Anyway, I'm not going to show you, they call moderators, yeah. So like they normally they visit and so on, but because everything is sent electronically, can I just say, you say they barely get moderated. This was like, it was before ChatGPT, it was like the 2022 thing, but I got 2 students that like got seriously marked down and ended up like 1 grade below their predicted over the total because they kind of lost, I think may have gotten 0 on the NEA. Because they use some code or followed some code from GitHub or whatever without citing it properly. You can use other people's work. It's encouraged. This is how scholarship works. You need to cite it properly. The breakdown, as I understand, is of marks distribution across the section of paper 1 is, I think it's pretty much, yeah, what Dominic is saying. Godwin, 37% section A, 13% section B, 13% section C, 37% section D, so it's symmetrical. Abdul Majid, I think you're meant to attach your code. It says people can get away with it. I know one will be able to tell. I think you have to look at what the Joint Council of Qualification is, but I would expect, because it's marked first by your teacher. A teacher doing it properly will kind of call you in and ask you to explain some of the code. And if you're not able to do this, that's a sign of AI. You're right, Hamza, that most AI detectors aren't even accurate. They are as much of a scam as AI itself. They're trying to sell in education. I'm doing a PhD on AI in education, right? So like this is you're been my jam. So I hope you're not going to regret having, I'm just going to like transition and doing 2 camera. You're not going to regret having subscribed to this channel because next year you're going to be at university. And like my PhD is about like large language model in universities. So I expect I'm going to pivot because as I do my research, it's kind of like nice to give low-key research previews, as OpenAI calls them. And so I'm going to put up some videos about generative AI and how to use it specifically in university. So I think it might be good if you're already subscribed to the channel. I'm just saying. Right, back to this thing. All right, we've done this, right? It's not code for any of the calling context functions up the calling stack. It will break the program. It will stop the program. Stop the program with an error. I love those, the errors. 7 fill numbers. Right, so 2 marks for explain. In training mode, always reset to the same I mean, Dominic, you're right. If it's easy to bank marks, if you think section C, but that's valid for everything. For some people, it's going to be another section. Then, like, think of it at least it's time that you can, you know, if you can blitz through it, that's time that you can invest in the others. Or is it the same list? And you can mention the list. It's like 2, 2, 8, whatever. Right? Yeah. Yeah. 2, 3, 2, 8, 512. In normal mode, is this where we remove? Okay, what's going on in yes. So fill numbers just filled, it doesn't remove, right? So in normal mode, the function is called after remove and makes up random numbers to make up 5 elements. So it draws, if you will, however many additional numbers you haven't used. That's 2 marks, training mode, normal mode. 8, convert to RPN. Lovely. Oh. Ace, I expect you. Ace is asking, are you allowed to get your NEA remarked if you think it is more? I think you're allowed to contest it. Like every board for every paper, whether it's kind of paper or NEA and so on. It's just, it's such an administrative like hurdle. It's just like so difficult, which is kind of annoying because like what it means is that basically even if you get the mark redone, that will not arrive on time for obviously for university. Which is why kind of like it makes it almost useless, and so fewer people do it, so it doesn't really matter that it's very time consuming, because if a lot of people do it because it's very time consuming, it will really swarm the board. Yeah, there could be a kind of like student strike to be done, where like if everyone decides that, well, you know, AQA this year was appalling and you all kind of agree to just contest and ask for your paper, there would be a don't this is gonna be, I'm gonna be in trouble for it. Okay. Right, 8. Convert to RPN. Store in the stack, operand separate immediately. Yes. Okay, explain. 2 marker. Why a stack is used to manage operators in this function. I do a radio operands. Yeah, to but also, so that's one mark I've explained. The second one is on so the order operation of calculation, computation of is respected or whatever. Yeah, because you kind of check if the one at the top is higher, and if it's higher, you pop that one. Precedence, it is written to the output before the one we have just read. You had to be there, right? You need to understand how the function works, but this is the kind of stuff they will fully expect. As a function of equal precedence, this is important, because although they are of equal precedence, you kind of want them in the right order. And this is the stuff I've not paid attention too much to, and did matter quite a bit in when I did a bunch of the streams and videos I've made, because I was using like plus, add, and multiply. And it's very important that if it's equal, if the precedence, if they need to be executed in the order they appeared in the expression. The operator on the stack had higher precedence because it needs before it is popped and written to the RPN output. Done this. 9, create targets. Oh, thank you, Dominic. This has been helped a lot. Yeah, so Bob is absolutely right. Like there's two truths. The first truth is that A and B are 50% and C and D are 50%. But the other truth is that coding, which is B and D are 50%, and non-coding, paper, like, you know, A and C are also 50%. And this forces you to always have the same proportions that we have seen, meaning that because kind of like B is making up, if you play with the proportions, if you make a larger A, you would need to have a smaller B, meaning you need to have so particularly if you get a larger D, you would also need to have a larger A so that everything would kind of even up. That would mean a smaller B and a smaller C. So I think that's why they always do it at 37, 13. Those number like sounds familiar, so I think that's kind of like that. But time-wise, it's very, very different, right? Like although section D is 37% of the total marks, the time they advise you to put on it is like much larger than 37% of the thing. So yeah, maybe start with C, get that out of the way first, then A, then B, then D, or I don't know. Like this is really up to you, but it's stuff that's kind of worth thinking about and knowing how to move on to the next question and securing those marks early and quickly. 9, create targets. The role of get target function and create target. The role of get target, I don't know. That doesn't ring much of a bell. Let's have a quick look. Get target. Oh, that's just like a random. This is the one that generates a random target. Yes. 9. Smaller than max target. Smaller or equal? Smaller? Random when it between 1 and this is kind of, I can't remember if it's included or not, but like, you know, kind of within the range. What's good about this is that if you word it like this, you don't have to actually commit to it's included. I think it's always including of the lower range, excluding of the upper, like range function, for instance, like the colon operators in lists. That's one mark, that's fine. And number 2 is the target list is different than the start of the game. What I mean differently than that. How the target list is initialized differently. I think they mean between training and non-training, right? In training mode, set hard-coded target list. In normal mode, create target. Right, create targets. This is the one we're talking about in this question. There's some, okay, mark distribution 13, 11, 39, 25, 13, 23, 39. Huh. Oh, so smaller section A, and they shifted the marks from like B to, no, I don't see the difference. A25, B13, C23. That can't be right. Larger section C. Wow. I mean, to be fair, because they have, right, so you know like how explaining how you do, there was like 4 marks, I guess, like the 2018 explained the evaluation, was it the evaluation or the conversion? Like explaining the RPN, how do you kind of evaluate it with a stack? Well, this is something that they would ask you in section C. So I'm not surprised they basically moved some marks from kind of A to C. What's reassuring is that, you know, D is the same amount. I only started like section D, and now you can ask me to do everything in all the papers. Right, it's explained differently, yeah. So create targets. Yeah, we give the size of targets. Size of? Yeah, with the first 6 ones, yeah. We'll create target, which I'll pick random numbers. Both leave the first 6 slots blank. Otherwise you would lose pretty fast. 10. This question is about the play game subroutine. Where the magic happens. This is helpful actually. We should have, this is a good one to start doing. Okay, so this is in order, right? So from left to right, first we display the state, then we're going, there's probably an input there. No, then, okay. As part of the description, you can assume the player enters a valid expression that only available number correctly hit one of the targets. So it's not a hierarchy chart, it's the chart of running, because that means you don't get into the errors. But hey, right, let's go. There's only, it only goes to F. It only goes to F. No need to panic. Right, so, play game. As the guy in Saw, I want to play a game. All right, first we display the state. That's fair enough. Then this is an input. Then we get number from user input. This is convert to RPN, that calls get number from user input. And then this is, we're still kind of at that level, so convert to RPN. Check all the numbers, number allowed. So the second check, right? The first check is check user input is valid. Convert to RPN. Check number input is valid. Convert to RPN. This one is check all numbers are used in string, which is called check valid number. This one is where we evaluate. So then this is D, evaluate RPN. E would then be remove numbers used. F is field numbers. And then we update targets and we're back in display score, right? So we're actually straight, is it display score or just display? Oh no, display score. Oh, I've got that previous question wrong. Then we don't call display state here, we display score. Never mind. Okay, so the point is I've got them all, right? So it's like, this one is check if user input is valid. Convert to RPN. Check if user input evaluation is a target. No. No, it's convert to RPN, sorry. And then it's C is... C is check numbers are all using all numbers allowed. We check is valid numbers, right? And then this one is check evaluation. Check if user evaluation is a target. D. No, that was D. C, that was D, right? D, evaluate RPN, which calls RPN. E, then, yeah, those are then the two of like remove numbers used and fill numbers. No. numbers used, and oh, I pasted instead of copying, and fill numbers. Last year's priorities, Maya, was something called Symbol Puzzle, which was a fun, which was, I think, like worse than this one. And it's not, and it wasn't because of the OOP, frankly. It was because it all like evaluated on some kind of like 2D grid, but that was like stored as a 1D thing, and you had to do like a spiral thing for. It was just didn't like it at all. Didn't care for it at all. Describe functionality access level subroutine part A. I mean, like seriously. The functionality, the purpose of functionality, so that's checks if the user input. Convert to RPN. A list of strings. This is kind of important, the typing of the thing. That the numbers, that the strings in the RPN in the list, like check that the numbers are all, yeah, I don't know, like check. Not allowed. Goes through the list, list of targets to check if any match. This removes them and scores the target as clear. Remove number used will remove numbers present in the RPN expression. Oh, I've messed up. Are all allowed without duplicates. This will remove the numbers present in the RPN expression from numbers allowed. I mean, and I'm gonna say like, see, literally, you asked me that. You literally asked me just like a minute ago. Yeah, in like C question 7, right? But like refills the numbers allowed list with random numbers. Well, I think, yeah, I think the 14 marker could be about RPN, yeah. I don't know what you could do about RPN, though. Like, the whole game is about RPN under the hood. Okay, ACE, the grade boundaries change every year because they just set the question, right? They set the exam, and then they look at what they've got, and they calibrate it all so that ultimately, yeah, it kind of, yeah. But the, yeah, the grade boundaries are, I would say, pretty generous and getting more generous each year. Because they talk about grade inflation and there's more and more high marks at the exams, but that's the grades, right? Like the letters rather than the actual percentage. Okay. A. So this is 1 mark. Especially for user input. Not for user input. What for user input? Like we validate the user input. That's why you want an exception. But I guess for user input, like if the user input an expression that divides by 0, see question whatever, right? There was something about the B, so this is like in 6B. So you want kind of like exception handling. Oh man, this is literally this, right? So like wrap the divide in evaluate RPN in a try block to catch divide by 0 errors. So this might be, oh, there was another ZigZag that might be a realistic section D1, and that's the one about having more meaningful error messages. There's also like the scoring bug because we do this, but there's 3 ways you can fail. Like there's 3 ways you can come out of this with a -1 without having actually kind of, thing. One is your input is invalid. The other is you're using some numbers that are not in numbers allowed, or you're using a duplicated number allowed. And the final one is it doesn't evaluate to the target. So that means that we don't check you might be doing a division by 0 until we try actually evaluating the division by 0. Which now, in fairness, because you can't get 0 as a number, right? And because you can't do brackets, you can't do like 3 divided by 2 minus 2 to do division by 0, because you can't do brackets. So you're going to do like 3 divided by 2 minus 2. No, because, but, the variance validation. So this is an example, but in fairness, we're kind of lying a bit, but we're kind of like, if you kind of show up your too smart thing, it's not actually necessary because you can't actually do a division by 0 unless you implement brackets or accept expressions straight up in RPN, which are questions that are those are coding tasks, but you don't need really to kind of do it like that. Play game, subroutine, loop, yes. And the player hasn't cleared it. So that means, right, so it's, yeah, if after playing, yes, if at the end of the game loop, not -1, at the start, index 0, right, of the targets list, it means that a further move left, yeah, would, yeah, it means that yeah, the game is over. The player did not clear the first target before it reached the edge. B, otherwise, infinite loop. Infinite loop. You need to make a product mark into 2 papers. Yeah, you're always kind of overthinking the. Hold on, the 14 marks. Yes, Mouse Phantom is describing the bug as saying there's one, but to see what it's replying to. Yeah, this bug, there's the scoring bugs. Yeah, we're talking about the bugs. Yeah, the bugs, there's a scoring bug and the thing. So this could we think we could be asked to fix, or maybe asked to comment on in the section C. Grade boundaries so high. Bob, as far as I know, the grade, they actually do like an average, right? So like paper 1 is 40%, paper 2 is 40%, the NEA is 20%, and then there's grade boundaries on the overall. So there's no different grade boundaries for all 3 of the thing. The structure of the hierarchy chart thing is like, it means that each, like the arrow means every block is a function, and the arrow means it calls in function. And you read them left to right in the order they're called. So I'm in play game, first it calls display state, then it will call check if user input is valid, then it will call check numbers used are all in, no, convert to RPN, this one, right? And then etc. And then you can tell, because you know which function is which, not only because of the order, but because get number from user input, this is called by convert to RPN, right? This is how we kind of like read the infix expression to convert it. I'm looking for other questions. Mecham, these questions come from the ZigZag set of, yeah, so this is, ZigZag is an offshoot of Craig and Dave, which apparently kind of have a stranglehold on computing education. Because, you know, being a teacher is like not a very kind of high paying job. So if you're a bit techie, you set up like, YouTube channel, you know, Smart Revise Online, that's Craig and Dave. So ZigZag at the start of the year, no, sorry, the start of the year, AQA puts out the preliminary material, and then in January, ZigZag publishes those that have, you know, explanations and crucially some kind of like coding and theory tasks with mark schemes that are not, they're not AQAs, but they're usually the best you can get to prepare, I think, at that time. Well, yeah, Otti is pointing out that, yeah, the NEA is well, not technically negligible, it's 20%, but it's true that like a couple of like small marks, you know, 20% is like 1/5, so 10 percentage point on the NEA is kind of like 2 percentage point on the final. But again, if you're close to the boundary, that could take you to a boundary. It's like there's always the same problem with markings and relative proportion. What you want to think about is like more how this relates to time. Like how much time are you investing to get like however many more percent on the final mark, bearing in mind all of the ponderation. And if you look at it that way, it's amazing how much computer science students are inclined to put like loads of time into their NEA, which is only 20% of the mark, but equally section D, that you know, preliminary program, that's 20% of the marks too. And like, I'm not seeing the same time being invested. I'm not saying you should equate it. Obviously, the NEA is a larger thing conceptually, but if you play it tactically, yeah. Section, okay, 14, no, 13. All right. Feature plans system, yeah, some information we will even need it. Oh, this is good because instead of a variable that will go, not persist is a technical term, between phase runs of the program. It's a 2 mark, it's an explain, where you would store this information, how you would retrieve it, needed. We would read the file at the start of the game. And then, yeah, we'd write to the file if the players, if at game over, the player has beaten the high score. Okay, I use a defined function that returns a list. I mean, there's been plenty of those. Convert to RPN returns a list. Right, so plenty. Right, convert to RPN. All of the ones that that touch numbers allowed, so like fill numbers as well as kind of like create target list. I think it's returns a list, right? Boolean variable within the main subroutine. That's obviously game over. I think there's only one. I don't even need to look at the code. Spend so much time with it. String variable, the function get number from user input. This is I can't like a string variable. Yeah, I hate this one. This is my worst favorite function. Number, for instance. That's this method using the targets. A list method. A list method. I mean, what is this method? Do you mean like a function that returns lists? Oh, a list method. Append, sorry, yeah, sorry, this actually means something. This is actually a method, because sometimes they say add a method when they mean like add a procedure or a function, but here like append and append or pop, right? Dot append, dot pop, those are methods of the list type class. Type class. Manager variable when the function main score, presumably, right? Surely, when you need to look at this. Which of the ZigZag questions, I think, accept exponents, maybe like a basic thing around quit or a basic thing around space, which I don't think was a ZigZag one. For the harder question, I'm not super sure. You may get like a special thing saying, we want, you know, the user to type shuffle, and then instead of an expression, and this will kind of take the list, reshuffle it, and then put everything at the back, so you get kind of all of the front space, but at a cost of 5 points. Like if you start looking at, you know, kind of more like game type thing, although ZigZag will tend to kind of like, you know, propose like true new features of the game that AQA will tend not to, because you don't have much of a time. The autosolver could come up. I agree, Mikam, M3 Cam, that it's probably too difficult for an exam question, but it's worth practicing, right? It's a fun one. 7 week exam, yeah. Maths was a beautiful paper. I don't know what you guys do in maths. I'm envious. I invigilated GCSE this year. They did the GCSEs in the morning and the A levels in the afternoon. So I was only invigilating the GCSEs. They're a bit boring. Okay, 15. Are we nearing the end of this? Yes. The plus. Okay. So that would be, you know, square 0, 9, bracket, close, plus. And that is the big one, right? The kind of, right, so this means I'm going to have this at least once, but potentially more than that. And then at the end, I've got just a final operator, which that's upper round. Yeah, I need like, obviously if you put a space here, it's kind of, you know. Okay, so that's the papa. BNF syntax, yes. I literally, because it's, yeah, because we can't, this is why we can't validate brackets. Yes, I don't. The answer's in the question. But so regular expression. Yeah. Its inability to structure recursively is what precludes them from validating back now. So like BNFs. Conversely, can be defined recursively. This had zero OOP. This was a surprise to everyone. I mean, you should see the forums of computer science teachers. They're all freaking out. The point is that, remember, like OOP, this is what I said in the streams before, OOP feels like a massive part of the A level, even for other boards, right? Because that's the main new thing, and that's the one thing that you will encounter typically early enough, because you would use it in your project. And so that feels like a massive thing. So seeing something, and because it's a clearly new code thing, seeing it that's not present in the way they evaluate the code stuff is very, very surprising. They could have it they could totally have it in section A. I think they could also not have it at all. Although I'd have like, I doubt it. But like, remember their brief, there's stuff that is not there every year. There's not a Dijkstra every year. I think there may be some assembly every year, but like you'd have to look at, we did that last year with my sixth formers. We basically pulled out all of the past papers from like, since 2018 from that spec basically, and just kind of like made a big spreadsheet of like what came in where. And this is where you find out like the big ones that can worry, like Dijkstra's not there every year, but also something we've learned from an AQA examiner themselves is that the brief is they need to evaluate the whole specification across 5 years. It needs to even out across 5 years. So it's okay for them to drop, drop a topic as long as it's kind of, within a 5-year period, it will be evaluated. That's the one thing you have to bear in mind. But I wouldn't, you want to be confident with everything rather than kind of like trying to guess what's gonna be, because imagine like you kind of make a prediction as to what's going on there and then you decide to kind of revise this and prioritize it at the exclusion of the rest and it doesn't come up, you're gonna be a bit communicatively, so yeah, so they count, right? The BNFs, 17. Precedence has the operators as keys, strings, and the precedence means execute first as values. Does it make use of this? So that's probably one Markov explain, right? And convert to RPN. On the stack by accessing precedence at key, I'm going to do an AG, for instance, right? Right, okay, boom. That's just you 2 marks for an explain. I hate those because instead of applying the skill, they actually like ask you to learn rote stuff about what the skill is. So this is a 2 mark. So abstraction. To work with a number of varied user input. Say convert to RPN is used more than once, I'm pretty sure, because yeah, so for instance, we could have like stored simply actually got it. The moment you add call remove number use, you actually have the user input in RPN, right? Because when you in here, you get this variable. The problem is that because it's a list, by the time you converted it, by the time you've evaluated it, it's empty. So you need to reconvert it again to find out the numbers to remove. Is more. It's used to just in remove number. Real functions with a clear purpose, well defined, whatever. Yeah. And there's modular, modularity. Could reuse DRY, etc. It's just like I hate talking about this stuff. 19. Finally, of the targets, shunting of the target moves. I wouldn't, is that shunting? I would call that shifting. That's like O-N. Doable in O1. Now those are not, you don't have to worry too much about this, but it's true. There's a ZigZag question that's like that. ZigZag task, a ZigZag coding question that's like this, but it can't come up on the exam because it's not testable, right? You're just kind of like refactoring the code on the hood doesn't really can't verify that you've done correctly. All right, so the mark scheme. Password. Yeah, Napoleon is not. I mean, Napoleon, you're correct in that in the hoop question, which was I think the kind of like keeping the state and having the stack of. They weren't clear. This could AQA could define it better because it wasn't clear whether the class they were asking you to make was like for the state or for like the actual stack. But the point is that you could look at it that way, but like you also need to understand OOP enough to be able to do the rest of the 11 marks. But you're not wrong. Like ultimately, don't stress too much the fact that there's no OOP, is it going to be OOP or whatever. Like you guys know OOP enough to be able to do it. Certainly by that point, there's nothing you can learn between now and Wednesday to do that. So 3954. Oh, it's because it's 4 sevens. It's the other one, 4761. Right. No. What is happening? Okay. Yes. Yeah, okay, so I've got this one. No, okay, yeah. One. Yes. The game's display current targets, number score, and score after every move. Okay, so I messed up here because I mixed up final score and not display state. Helps the game keep track. Yeah, obviously, and especially they wouldn't be able to know how, like, what new numbers they got. So it's not just keep track. It's like they need this information. But yeah, obviously, reverse position application. It's a list of strings symbols using the expression. You mentioned there's only one mark on this, but I didn't actually put that here. I put that somewhere else where I mentioned it was a list of strings because there's only a one mark. It writes for each valid number, matches the number is removed to prevent reuse. Gets removed from it, yeah. A, B, was there a C? B, 4A, scores increase, no. Scores increase in the value of this question matches whatever the current target. I think that's like just saying nothing. The player score increase. What was the question? I'm sorry. What's happening here? Oh, yeah, okay. So what should that was the thing. So this is when it happens, and it is when evaluation question matches one of the current targets. So it should be in targets, matches one of the current targets. Remove it, -1 for hate of use. The screen starts with one normal number and ends with the digits. Swing matches criteria, item screen is valid, can be cast. That's why. So casting would throw an error here. Without the plus character, the function only match single digit integers. Yes, that's what I said. 13 would be invalid, or 10. Follow the operands. Pop from the stack, push back onto the stack. That's the classic one. Function would crash because no specific handling expression. Yeah, I've kind of like been a bit verbose here in 6, but yeah, no handling. There's no exception handling for this. In training mode, it's always fixed. Between random inclusive. Oh, gosh darn it. Yeah, okay. So for random rendint, random.rendint actually is going to be inclusive of the boundaries. Stack correct order based on the precedence. Based on the precedence of managed ordering. 8B. Flow aside, those are the zigzag stuff. Like I'll say the same thing, right? I got them from like a subscriber of the channel, right? So like some of you have them if they work with them at school, and I'm sure that you can talk amongst yourself and find it. Again, might be a bit late for this, but I don't know. No, to be fair, that would be useful to have by Wednesday. A matching precedence popped off and output precedent operator. I mean, I feel like they've not explained why we're doing this, because if it's equal, you want them in the order they were in the infix, because that matters for like subtraction and division. Gets target number, target when mark target, training game target list, yes, always the same set, a random gate we build 5 minus 1. Oh, I said the first 6, whatever. That's the correct label. I know it is. I've just literally explained that. I'm very confident about this, right? Fresh copy of the training numbers or random numbers. Expression, we're 11. Exception handling, catch and management time error, invalid input calculation, division by 0. Yes, doesn't crash, doesn't make a fully. Catch division by 0, allowing the program to display an error message. Yes, except that you can't divide by 0 because you don't have brackets. And you don't have zeros as a valid number. How would they mark question both coding and theory? Obviously, they're not going to be the ZigZag questions, but like they mark questions. Like if you go in physics, I've done a video about this, right? You go in physics and math tutors, you will find the mark schemes, and you will find the mark scheme for like section B's and D's, right? Change the add method and so on. So it's all kind of, you know, alternative answer. I mean, this is okay. Admittedly, yeah, they will kind of give you some example solution, but like look at the marks. It's like every exam. Look at the mark scheme and look at what they expect, and that way you can find the better way to do it. Well, theory question, it will just be theory question. Like we're just doing mark schemes of theory question there. This is just like knowing something and illustrating with the thing. So, you know, like exception handling, what would you use it for? You would use it for divide by 0, which was like 11, right? 12, any 2 from. So target not at the start, the game is over. So 2 from. Oh, there's the score one, right? True, no longer available. Yes, prevents the loop from running infinitely. Yes. Here, store it, file or database, start with files to retrieve after each game with a new score and add the new value. Yes. All of those, create target, fill numbers, the one that return a list, running game, those are kind of variable types. I mean, this isn't something at this stage. 15, use to denote one or more integers. This is this one, as well as this one. And yeah, one or more. Which, oh, sorry, I didn't mean like one or more, the preceding is imply of this, like one or more, that kind of pluses. One or more of whatever's in the brackets, either square or round before it. No, regular expression do not support recursion. This is literally in the question of the thing. I can refer to themselves. Where it's like obviously BNF scan. Yeah, regular expression have no notion of state. That's right. That's a good one as well. Precedence of the current, compare, the top stack is popped out, final single checked, precedence if not detected. What was the question here? 17? So it makes use of, I spoke too much about precedence and not so much about what it does in convert to RPA. And decomposition, burdens, from task abstraction, hiding this complexity, clear high level. For it's O of n because n elements and expression will be carried out. Okay, someone asked for something like a recursive, what is it, like a recursive solver as a treat? Yeah, let's do some. That was okay. That was like so boring. I hated every minute of this. I know you needed it. No, I didn't hate it that much, but I say this is not what I like the most about the AQA computer science. What's great about the board is that it does. It has this own computer exam, which gives you the opportunity to code. Admittedly, code in exam condition, it's not very kind of, it's 17, 19? Yes, 19. All right, so, yes. Oh, wow. There's like a, oh, there's a dump truck outside. I'm feeling a massive bass. Yeah, last year it was in the afternoon, which I'm so much of a morning person, even as a kid. But I know that teenagers their chronotypes will tend to shift. Let's not call it not original copy, but Z19. Mega save! Exclamation mark. Okay, so we want like a hint, or like we want to give a offer suggestions if selected, right? So we prompt the user. Remember that we can play game, and then in here, upper, I only check the first one. If that's equal to a big ugly capital H, we are going to. This is gonna do the displaying of it. It's like display hints or like, yeah. Now display hints, we are going to need, of course, the targets and numbers allowed. And I'm just gonna make it over here, right? Targets, numbers allowed. Right. Right, so if I were to define it as a BNF, an expression is, and this is like the, it's like the regular expression itself. The regular expression is not recursive, but it's you can build it with. Okay. I need a separate function, right? So I want to say def. Def generate expression. I'm only going to use the numbers allowed. This takes operators, needs a list of operators, right? And that is plus, minus, minus, star, divide. Oops. So I've got the. This is my recursive function, right? So I want a base case and then a recursive case. This is going to be something that will generate all expressions from numbers allowed. With up to n ups. Right? I want to generate all expression that can do from numbers allowed with up to n ups, where n is the number of operators. I've completely broken the case, like the Pascal case of the thing, but this n ups, right? So my base case, if n ups, if I ever get asked, can I return all of the expression from numbers allowed with 0 operators? So we will return numbers allowed is integers, so I'm going to want to cast it to a str of numbers allowed numbers allowed 0, yeah, right, because it's the only one that's the only game in town, the only number in the list. So I don't need to make that an else, but implicitly this is an else branch, because otherwise I would have returned from the function. So otherwise, let's go, Brendan. All right. Now this is where I want to return a list. I don't know, I'm going to do the thing with a list. I'm going to... So for op, no, for odd, for operand in numbers allowed, could do a yield, but if you don't know about like iterators in Python, you can kind of do just in, it's like return, but like you return more than well. So your like your indexing operator on what do you mean on list will kind of use yield, but that means you need to return a list, which is kind of annoying. Hi. Okay. Otherwise, output, I'm going to need a list. And for op in operators. And I'm going to append to the output am I going to append, or am I going to extend, I think. I need a console. All right. Okay, so let's say I've got like S, and that's like 1 plus. Okay, and then I've got my list, and that's going to list of like what I can stick at the back of it. So maybe that's like, 2 times 3, and like say 2 plus 3. And if I do them in different order, I will also have, say, if I'm just doing like the plus and minus, and the plus and multiply because I'm weak. 3 times 2, in the right order, whatever, kind of like n 3 plus 2 in between quotes. 3. So this is what is going to be returned from the lower kind of order, the lower, the next call, the recursive calls of the thing, right? And I want to generate, oh yeah, I'm going to, because, yeah, no, sure, I get this. I want to generate a list that's going to be like S plus E for E in L. Super, right. So all I need to do is extend the output by the list of, wait, where's S in that instance? Yeah, so a list make, okay, so numbers allows, so extend, I'm gonna say string of odd. Let me decompose it so you can see what's going on. I'm building like the little bit of the string. So here I'm in say 2, and then here I start with plus, right? And for each of those I want to say this is going to be the operand cast to a string, and to which I concatenate the operator. I should have really called it OR if I operand operate. Except I can't. It's not operators, and this is OR, right? So, and I've got, so I'm going to extend this by a list comprehension, by a list made of all of the concatenation of S and another bit of expression for all of the other bits of expression in, and okay, right. So this is also I need to make a copy of the list. Okay, so for I numbers allowed, I'm gonna have operand is equal to numbers allowed at index I, and then I want to rebuild. Why did I get like, what's the problem here? Oh, shoot. Yeah, so I'm just going to go back to op for operators because, oh, of course, or means or, right? No, Bob, you don't need to put change code and change thing like the people. I mean, if you want to help the examiner, you can just kind of like add some comments by all means, but you don't need to be as formal. They would, you know, they mark you on the code, not the comments, but the comments will help, might guide the examiner towards your code. Right. So where was I? So I'm iterating explicitly with a number. And that's not range numbers allowed, by the way, that's range of length of numbers allowed. Obviously, you would have corrected this yourself. And for each of the operators, I have my operand, I have my string, that's the operator and thing, and I'm going to call like new numbers allowed are, and this is when I get back to my Python. So L was this, if I want L1, that's 2 plus 3, so L of everything up until 1, that's just this one. And then L from 1 onwards. Yeah, but I don't want this one, so like plus 2 onwards. And the good news about this is that if I do it like 0, 1, 2, 3, if I say 4, it doesn't break, although if I were to say L4, that would break, right? But if I say, oh, give me from 4 to the end, they're like, oh, that's just the empty list. So I don't have to kind of do an if for the thing. The new numbers allowed becomes equal to the numbers allowed only up until I plus the numbers allowed from I plus 1 onwards. And then we extend S for E in, and E we're going to call, here we go, there's the recursion. We call again whatever I call the thing for E in generate expressions. So that's why I've returned it as a singleton, right? As a string of one element. What is annoying is you have like 2 times 1 plus 3. Out of context, I can't. Oh, what do you mean in my thing? Oh, but that's fine. That will be code. That will be code. This is not meant to be an exhaustive demo of what's going on, right? Obviously, the real case. We'll use breakpoints to trace it in a second. It's going to be fun. Everyone loves recursion. Okay, so we generate now the expressions from like the rest of the numbers that are allowed, and this time only up to n ops minus 1. So this means that we're going to make, like, it's not only recursive, but it's kind of like, you know, the first one's going to call like 4 more, like 5 times 4, 20, right? And the next one is going to do 4 times 4, 16, and the next one is going to go, you know, 3 times 4, 12, etc. Now, of course, yeah, there will be kind of identical expressions, but we'll kind of share those in a minute. Identical, if they evaluate to the same thing, we only display display them once. So I have now, right, in here, I'm iterating over here, I'm building all of the possible first number and operator, right? No, I don't, because numbers allowed colon, well, let's have a look, right? Numbers allowed, so this is my L. If I do L colon, we need I plus 1 colon, by the way, right? Kind of we can't do both. The colons are like, because you can parse this by saying give me from like 0. You know about this, right? In Python, you can do like give me like from 1 to 2, and that's going to give you inclusive of 1 but exclusive of 2, right? So I can 1 to 3, 1 to 4, and then 1 to 4 in steps of 2. Right, so you can also, you get the 2 colon with like the steps. So going this one, then that one. Anyway, that's kind of beside the point. Yeah, we're just going to generate every expression by brute force. That's the point. But this time we're doing it recursively by popular demand. Like that's literally one person asked. But like apparently I was told the mark scheme per this does it recursively, which expects recursion. Which mark scheme will always allow both. So do whatever you're comfortable with. Okay, so here we generate, we call that however many times, and then we're going to kind of regenerate this big kind of list of outputs. And then once we're done with it, we're just going to return output. I'm really doubting it's going to work, but the beauty is that I can now import now from Z19 underscore import generate expressions IPort, like the dessert wine, the fortified wine that Apple makes. IPort. Right, so if I generate expression, it's not gonna work. It's not gonna work. Generate expressions with okay, let's keep it simple. 1, 2, 3. Yeah, let's 1, 2, 3. Well, 1, 2, and 3. And I want all of the one up until 2. So that needs to match, right? You're kind of like n. Probably don't need the. I need to accept it. No, maybe I don't. I could just kind of say just like -1. I could just say this is kind of, yeah, that should. I don't really need to have the. I'll see if I can improve it in a second. All right. 1 + 2 + 3, 1 + 2 - 3, 1 + 2 - 1, 1, 1, 1, 1, 1, 1, 1, 1, and then all of the start with 1, then all of the one starting with 2, and then we can like do it again, and yeah, and I think that's that. Now a bunch of those are invalid, a bunch of those evaluate the same thing, and so on. But like as a brute force string generation, yeah. Jay, we don't need to calculate the total number of possible expressions to generate every single one. Once you've generated every single one, you can just count it. But you know that the total number is, we get 5 numbers allowed and 4 operators, right? So we get 5 possible starting number and then 4 possible first operators. And then from this root, we've got this 20 different possible routes like that, and then we kind of build it and so on. So it's a combinatory calculation. I don't know if you do this in maths or further maths. I did it in the French curriculum, but yeah. So I think this has worked essentially. So we are, but I might need to just say. Length numbers allowed is equal to 1, and then yeah, the 0 ups. I don't need to put that because those things are too related. And now what I'm doing here is like n ups started as so here I've got it's the length of the no, because I don't pass n ups anymore, do I? Yeah, I don't really use it, so it's just kind of like I don't even need. This is gonna. It knows that basically the number of operators you can generate. Like so it's like the length of the numbers allowed -1, right? If you get like 5 different numbers, you can generate expressions up to 4 operators. So we've got possibles for in one word, perhaps. Possible expression is general expression number out for exp. In possible expressions, we are going to RPN exp is equal to convert to RPN the expression, and I'm going to then do a try block evaluate the expression, the RPN of the RPN expression. Do nothing. That means this was just a division by 0 or something. evaluate RPN. So a bunch of those, if you end up evaluate RPN, return something that is like not an integer, it will like return -1, I think. Right, RPN, and if it's not that, yeah, return -1, right? So, oops. If val is not equal to -1. Oh, and then I also need like found target, so I don't kind of, so first I want the value not equal to -1, and if the value is in, okay, so value in RPN will return a thing, and the targets are also in. So this returns an int, val is an int, everything's an int in targets. If val in targets end, val not in found targets, we are going to append val to found targets. Yes, Oliver's get it. Yeah, this is C and P's combination. Like how many different, kind of thing can you pick out of a, if they repeat or not, and so on. And here is like the one they don't repeat, as opposed to, if you could use duplicate numbers from your list of what they call available numbers, then there's no limit to the number of expressions you can generate, because they can be infinitely long. So we append the val to the found targets, and we are going to print exp equal val. And look, I'm struggling to believe that it could be that simple, but I think this is it. I can't believe it, but seems like, trust your code. All right, let's have the training game, because we know and love it. Let's ask for help, and everything breaks. Nah, there's more than this, bro, isn't there? Surely I've got like, no, that's not right. That's not right. Okay, because like if I, hold on, I've got a Z19, I've got, all right, whatever. I've got like a Z19 obviously somewhere. This one we've established worked as well. We can probably, oh, I've got so many of them. Open. Okay, the iterative Z19 that we did like 2-3 weeks ago. Okay, this one, and if I ask for help, but that's not all of them. Why? This was working. You guys were there, but not say you personally, but like this was working last time. All right, so when in doubt, just chuck a breakpoint on it, I suppose. Okay. So I might put a breakpoint here so I can have a look at possible expressions. All right, let's debug it. Could there potentially have something like this? I doubt it, right? Because it feels like it's a bit, I mean, because it's very simple, right? Like it's actually fairly simple to do if you do it recursively, but it's actually a bit of a stinker, and it's kind of like you end up with a lot of nested code that's ugly, and you need to remember not to like use different variable names in case you mess up the list and stuff. Like because it's a bit tricky to do iteratively, I think it's unlikely they would. Same deal, the brackets, I don't think they would, but like there's a couple in the ZigZag task that they might be. I still don't know what the, but they keep you guessing for the 14th and the 16th and the kind of high value tasks. So, okay, so I'm pressing help. No, and help. Yeah, possible expression is like this massive list of all of the things. But this is the problem. I have forced it to. I see my problem. So this will actually generate. I don't know why the other one doesn't work though. This one, but like this will generate all of them. So I should stop sooner. Right, so this will generate. It will not generate any of the thing with 3. But then I need to get back to the NOps. I need to I'm back to the. I know I needed this, right? So like no, because how do I? Yeah, when you build them from the bottom, from the back, right? So the last one plus the just I need, because when I build it from the start, I could kind of add them, you know, once I've got 2 operands and operator in the middle, I add it to the list of expressions here. I'm not sure. We don't do open file from like the. I guess Z19, haven't I? No, just go Z19. Fair enough. All right, so back to NOps. Well, how will I know which ones? I don't know. It's a tool. How is it a tool's gonna help me here, Oliver? Because yeah, I'm very sorry if you've been working VS Code, you didn't know that this. It tends to be the universal thing, by the way, like next to the line number. But like, how would it's a tool help me with this one? I think what I want is go back to NOps, and so if the length is that, and then if otherwise. So I'm picking the first operator, I'm picking the second one. No, my base case, do I need this? Yeah, I think I want a, we shouldn't get to that base case because we'll probably hit that one before, because this one should be, I want a base case that generates a full expression and doesn't recurse. For up to in. So this up to is in numbers allowed up to. I need. So I need to have an explicit integer iterator, and I make my O1 at I. So then ha is I colon plus numbers loud at I plus 1 colon. It's colon I, isn't it? It's colon 1 I. Oh yeah, okay. So that yeah, it's a look at the permutation thing. Yeah, but sure, but that doesn't. How do you get that gives you all of the permutations in 1, 2, and 3, but I mean that's the easy part, because then in the middle you want to have like any of 4 operators and kind of extend it like that, and then you kind of permutate across larger and larger things. So I'm sure, I don't know. I think I don't know if like the thing that it's the permutation intertools kind of like helps with is saves us that much code, but I mean it can do it differently depending if it's recursive or iterative. So this is O1 plus up plus O2. And then, once I've done this, if my nops is 1, I'm not going to be able to get down further, I'm going to need to return output. And here, otherwise, so this is like 2 operand expression, and then, and crucially here I'm going to pass n ops minus 1. Anything larger. So if I've got this here, Python generate expressions from a list of numbers, like, was it like 2, 2, yeah, 2, 2, 3, 8, 5, 1, 2. There's going to be a lot, but I only want to generate, say, the 2 operator expression. And I feel like I'm missing something. Yes. Ooh. Oh, I need to cast, of course, I need to cast a little something to a... I might do it here. No, stra. This is stra. All right, query over here. Come back in, load it again. Try it again. Nah, I've just, oh, I didn't save it. Okay. James is asking, is that true? Oh, my teacher said he approved the ZigZag question. The question is similar style, but the question themselves not the one in the paper. Well, you don't have, like, AQA doesn't need to have approved the ZigZag question, but clearly ZigZag question, as I said, is the best resource. I can't tell you that none of the question will be in the paper. I would have to check. You can, I don't know, maybe you would have to, I'm getting an archive of ZigZag. I've not checked if that was the case. I think it really doesn't matter. The point is that, yeah, ZigZag is the best you can do, and although it doesn't do it as detailed as AQA, it kind of breaks down what you need to do, and then has a mark scheme that verifies what you need to do, and it has a test case, which is like, there's no other kind of questions on the market that kind of do this. Beyond this, you know, I don't know if you can expect, oh, it's not going to be, because ZigZag, remember, is like, you get to pay to get ZigZag. That's why not everyone here has it, and even I didn't pay for it, and I got it from a student, right? So I don't think that AQA will say, oh, you know, for the small proportion that like may have been lucky enough to not only get access to ZigZag questions, but like work on this, we're going to deprive ourselves from something that would be like an obvious question that like, because the ZigZag questions happen to be like based on the WikiLeaks questions, because people submit stuff to WikiLeaks, Wikibooks. People kind of populate the Wikibooks page, which I have like lying around. Like we were looking at it in the early videos, not a new tab. I'm not completely psychopathic. Yeah, Wikibooks target clear, right? So this stuff, that's kind of like, if you look at the page history, as soon as the thing is published, no, sorry, I won't like, if you want to look at like when that gets created, found per page, right? That gets created in September, empty template, like people ask the thing. And then you've got section D prediction based on the NEA, right? This is all in September. And then people have like section C prediction. Oh, there's section C. And then people ask their questions. So people ask their question throughout the year, and then in January, then ZigZag publishes their questions. And in fact, like there's only like the exponent is like super obvious, right? It feels like it's something that would be helpful there, particularly with the test game, because you get like a bunch of 2s. So you can do powers of 2s and stuff like that. So I disagree with that. Like that means that AQA has guaranteed that, like, based on one private publisher, like an exam board is going to affect the question they choose to make sure there's not a repeat of this. You must be joking. No. because remember, like AQA have defined their questions along. By the time when AQA publish the preliminary material, they have the questions already. They're not waiting to see what's in ZigZag to make sure they don't have anything. It's like, you know, ZigZag is influenced by AQA, not the other way around. Get the kind of like, you know, power structures of computing education in the right order. Yeah, okay, so those are all of the expressions with 2. So which means that now I can have something where it's possible expression equal no, I can't do this. I can't do this with this comprehension. I can just do like this. All of the 5s plus can I not break it in a no? It's not gonna like it. All of the 5 plus all of the no, because that's a list actually. So yeah, this is where I can do this if I have opened a square bracket here. So I get the list of the expressions from at 5 operators, and then those at 4, and then those at 3. I might start kind of like on 3s and the 2s. And the 1. Cool, everyone's very happy about this, and that should stay the same. All right, so let's try. When you say the challenges, Alex, what do you mean? No, so Oliver, again, like I've got a video about section D. You're not gonna get any marks for like elegance or whatever. Like it's literally they verify, have they created something the right name? Does it use an iterative structure think of like, you know, when you see the question, regardless of the way to code, there's a couple of definite things that will be there, and definitely if they give you the name of you know, function or whatever, that's going to be one of them. But like you can't do certain things without having a loop or having a flag, a boolean variable or something like, or reading something from the input. Those are the things they validate. So, and this, I'm sorry, like this, you don't need to have like access to all of the private ZigZag stuff. Literally go have a look at some section D mark scheme. It's not going to be the same code. You don't know anything about the code, right? But like the type of, you know, kind of there's an alternative answer using recursion, but like here's one that's a chunky kind of 8 marker, right? So create variables, store the variables, iterative structure. There's nothing about like performance, simplicity, elegance, and so on. No, you can't. Hannah is asking, can section be BU? Definitely not, because you can't make a 25 minute coding exercise. Well, unless it's like, sorry, you can't make a 25 minutes exercise of OOP that you can clearly verify with a test case. So you could have something where like, oh, create a class and that should have a method that will read the user input and do, you know, some calculation and print it out. But like from the test, you wouldn't be able to test that you've done it a certain way. You would only test kind of functionally inputs and outputs. Here we go. Ooh, I've got a little bit much in there. Yeah, I may have a little bit of a problem here. So, well, yeah, a crabby boy, this is, you better, right? Like surely from year 12, I mean, I don't know, like this is how I do it, but I think that the best way to prepare the kids, the students to section D is to practice it with previous skeleton codes. So definitely I get usually more like the beginning of year 13, because then we have the ZigZag tasks. I get them to look at last year's, and yeah, so you know, we will look at kind of symbol puzzle, and before that Dastan, and before that Breakout, and before that Text Adventures, I want to say. I'm not 100% on this. All right, let's kind of debug. Do it. I'm not running a debugger. You tell me I'm doing a debugger, I'm not running a debugger. That's a lie. I guess I want to start with no, I think they could be. You could have, if you have a sort, it would be a insertion or bubble. You cannot implement a merge sort without recursion, and boards are scared of recursion. No, you can't have a merge sort. You could have a, again, Kongs 06 can be a BFS or DFS traversal on section B. No, because section B, you start with like blank code, and like it would take you, and it's meant to take 25 minutes, and like just to define a tree, define a class of tree so that you can do traversals. No, tree traversals are definitely section A stuff. In fact, maybe your what you might call it. Well, no, because it's going to be a graph. If there's a matrix, could be a tree, who knows? But like it looks like that in your EAD for section A, there's like some tables. It could be it might be Dijkstra, it might be a tree. All right, so my targets, my possible expressions are, I appear to have a lot of them. I think that that's too nested now. So I've got like a... So it's a flat list, except it's nested by, and then I've got the smaller ones at the bottom, which is kind of how I wanted it, but I don't understand. I think that's because, no, I think that's because, yeah, no, actually it's because I did it. Is there like, can I like do this? Because it feels like I can't break, Python will not let me break an expression on several lines. Yeah, that should, is that gonna work? Yeah. Yeah, section B, yeah, Sebastian, Hannah, you're not wrong. Like section B tends to be something that you can kind of code in 25 minutes. It will tend to be ask the user for an input and then do some things with it. And so as such, things that are arithmetic are definitely, kind of, so the past examples were like, okay, do you sum the digits and then does it sum up to its thing? You might need to decompose, some kind of, the stuff on Project Euler, it's kind of quite typical of, yeah, so this isn't, yeah, it's not a hash. It's like, it's just something out because, fine, I'll just put it on one. I will put it on one line because no, yeah. 1, 2, 6 exclusive, so 0, 1, 2, 3, 4, 5, and then plus equal. I should have written that in the first place. I don't know what I was thinking about. Okay, I'm feeling lucky. I'm running it without debugger. All right, help. Cool. All right, fine. We've done it. We have done it. No, binary tree. A binary tree. Devansh is asking Q3.5 is a big table coded binary tree. We have been over this repeatedly. It's most likely tracing the Dijkstra algorithm exactly like the 2018, well, very similar to the 2018 question paper, which we done earlier in the first hour of the stream, and I've done a specific Dijkstra thing. I think on the live stream, it's not a dedicated video, maybe 1 week or 2 ago, but you're gonna have to go. Making copies of the numbers aloud and stuff like that. Well, yeah. The solver is the one we just did. Let me stop. Am I running? Is this running? This is running. One of the questions was adding exponents. That's likely. Okay, let's kind of go back to the basics, because I'm guessing like there's like you know, 24 viewers, and you're all in a panic, and especially I'm thinking of those that those of you that are going to find this tonight, or like more likely Tuesday night, right? If you get, I might make some more videos, but like say you get something like adding, well, we've done this, the adding the practice the basics, right? Because like your five marks, 6 mark questions, there's going to be something like, accept exponents, or kind of quit the game, accept spaces. This is the one that there's several. So the idea, like the relationship between the ZigZag task and the AQA task, is that ultimately there may be some similarities. There's definitely ZigZag tries to approach the way the questions are asked and the questions are marked, and they need to be tested. Although, as we've seen, for instance, here, yeah. So this is daft, because you can't test that you've actually refactored. So you can't. The test is kind of just a refactored test. I've not known AQA to ask some refactored question, because if you don't change the code, you can still get the mark for the test. So I encourage you to do this if you ever get a refactoring question. But yeah, that was an interesting one. That would have been a good, so kind of stuff that kind of changes the functionality of the game, where like it gets a new, completely out of left field, kind of, let's have some new stuff. So I think there might be stuff like, all right, let's say I've got I'm going to make a duplicate. I'm going to copy that. And I'm going to call it shuffle. T-shuffle. So allow the user to type shuffle instead of an expression. Should shuffle target list and kind of pack them all to the right. So all spaces at the front. Right? That could be something you extend the game, or like sort. And then you could have something where it's like sort the list and it forces you to do bubble sort. That would be a bit cruel, but ultimately it doesn't need to be a great game. Right? It doesn't need to be like a task that makes the game better. It just needs to be a task to test that you're that you can kind of not like kind of understand the skeleton code and can do some Python, I suppose, right? Or well, yeah, we're in Python, but there's a colleague of mine that, like, kudos to him, has done is doing a video series a bit late in the game. He's got a brand new channel called like Last Minute CS Revision, where he's doing the same thing but in C#. And coming from Python, looking at it in C#, I recognize obviously the logic, but because it looks like the mirror world, the upside down, Stranger Things. All right, so in here, I want in play game, classic thing, an expression, or for a cost of 5 points. Right, I'll shuffle. So here I'm going to say classic, like if user input. Those are kind of easy to do because you're not really touching this, you're just kind of getting out there. If user input dot upper bracket, call the method. Don't forget to call the method, because Python will not break. It will give you an unexpected weird error. If that's equal to an uppercase S, is equal to an uppercase S, we are going to reset our targets becomes equal to shuffle and pack, which takes targets. Okay, and let's def it. What's def? Text list of targets will return the shuffled and in the middle, so there's one over there that does a, when you update targets, update targets will, oops, does this kind of weird iteration from the back? No, it doesn't. It does an iteration from the front. Oh, there was another task where I was going to be iterating from the back. Yeah, absolutely. Although you wouldn't need to sort it after every turn, because like once you've sorted it once, all you're doing from the list is removing stuff from it, so it stays in order. Although if you start considering the -1 will be at the front. In fact, like if I've done a shuffle NPAC, but if you're doing a sort NPAC, that would be so much easier because it puts all of the -1 at the front. Look, San Koban is absolutely right, and they could ask you something like that. That would be a decent 14 point. 12 or 14, whatever the high value marks you have. So there's a random shuffle, and we've imported random, right? So in Python, and it shuffles in place. No, because the merge sort, Nepali man again, well, you could trace a merge sort, yes. You could trace a merge sort, but I don't know if you need that many columns in the table. It will be something, because you would have like the order of recursion, like which kind of like levels of call you're in. The merge sort is definitely something that's much more of a trace than it is a write it. Although it's not that difficult, but like people are scared. Right, so we'll get a shuffle function that does this for us. What I want to do is kind of like get all of the -1s. I'm going to split it, right? So I'm going to say x for x in targets. X is equal to -1. Simple as that. And then the values are to go at x for x in target if x is not equal to -1. So this is going to keep the order, right? And then I just say targets becomes equal to the empties, which I put at the front, plus random dot shuffle of the values, and this returns the targets. So this is because it's a shuffle. A sort would be kind of a more realistic 14, like for the 12, 14, like higher marks question. So if we now try it, let's have a trading game, right? And then let's clear something like the 64, right? So 512 divide 2 divide 2. No, is it 512 divide 8? Plus 2 plus 2, yeah. Cool, cleared it, and the shuffle, and I did mean targets with a capital T. Thank you, you're helpful. Which is where? Yeah, okay. All right, I've been like, oh my God, it's been like 160 minutes that this has rolled over the 100 mark. I absolutely need to do. I'm gonna kill it after this one. I wish you a good one. Okay, so let's do the 512 divided by 8 plus 2 plus 2. That gets the 68. And then if I shuffle, it doesn't work. All right, let's put the breakpoint and debug it then. It's possible. The problem is that they don't dare ask the bubble sort on the exam because they want to find out how terrible the students are at it. Okay, what have we got? Targets is -1. The empty is -1, -1, and the values is that. Like, what's the problem then? Okay, do I need to kind of, I don't know why. Fine. I'm going to say values equal random shuffle of this. Random shuffle. Right, I'm shuffling this as I get only the non-empty ones. So I need to stop the debugger because it's dumb comment and everything. And then I don't need to do this again. Right, I'm going to do it like this, save it and run it. Need to be. Yeah, okay, we're running. Yeah, 5, 12, divide, 8, divide. No, divide it plus 2 plus 2. Cool, and then shuffle. Still not working. But empties was not a... Ah, no, hold on. Well, then let's kind of run and debug from here. Man, the bubble sort, you should have done that from the GCSE, frankly. Easy peasy. Right, what's the problem here then, right? Targets values is none. Why? Okay. I will come back to this, but it's not the, I think I will do a video where it's the same thing, but with sort. Like, so it's the player can type sort and it will kind of like sort them all. What's good is we don't have to kind of worry about the -1. They'll come to the front naturally. The front is kind of for you from where you're looking at, right? But I've been like streaming for like 2 hours and 40 minutes and I'm really in the toilet. So best of luck. Kill it on Wednesday. I'll put something out hopefully before then. And then I have put a video about a paper 2 task for the AQA